No, just because I have to share the presentation with another person that will be not present today.
Okay, it will be in the group, so you can download.
Yeah. Thank you.
Davide joined presentation. Ciao, Davide.
Hi everyone.
Ciao Davide.
It's better not to open the emails now, Simone.
We have to be multitasking, you know.
Yeah, for the sake of privacy. I think that's why Skype is asking, like, before I start recording, they are asking, like, legally, should you really want?
Probably you are right, yeah.
So we are almost a minute go, but I think let's wait for 3 or maybe less than 3 minutes more to
Okay.
make the
No
count.
problem.
Needs to be more than 15. So you will get like an extra 3-4 minutes for question answer session. Yeah. So everybody can roast Simone today. Usually we roast everyone. So
Yeah.
is there anyone in any other meetings? Anyone know about that?
Oh, I don't know, actually.
Is there meetings going on now? Like around like this time, 11:30? Any group meetings, team meetings?
Nothing that I know.
I know Marcelo was having a meeting at 10:30 because I was in the meeting before.
Okay.
But I don't know with whom. So
okay.
It can be that that it was a WeNet meeting maybe or something like that. So maybe also Fausto was involved. I don't know.
Okay.
Something long.
Let's wait for 2 more minutes and then start, okay?
Yeah.
Ciao, Fausto.
Ciao, Pasto.
So we can start. Welcome all for this week's seminar. I'm happy you guys are joining this week. And this week we have a seminar from Simone Bucca in our group. So he will give you more on this. Simone, go ahead.
Thank you very much, Nando. So, hello everyone. And first of all, I would like to say that the seminar today, as you can see, is on iTelos, so our data integration methodology. iTelos is a very huge project, so includes huge amount of different aspects involved, different works and so on. So I will try to provide you more complete as possible overview of iTelos, describing all the interesting and most important aspect. But of course, I will leave out of my presentation something. And but in any case, if you have some questions regarding that, of course you can ask. There are a lot of different details, more at low level maybe, that are interesting and challenging. So if you are interested in it, you can please ask, or we can also discuss in a separate meeting. So let's start. And so iTelos, a data integration methodology. And this is the structure of my seminar today. I will start to introduce you what I mean with what we mean with data integration project. So also describing why we need the data integration in our work, in our life, let me say. And then I will propose you our solution to address such problem. So our solution is our methodology, iTelos. I will describe the structure of iTelos methodology and the users involved in the methodology itself, the resources as part of iTelos that are managed by iTelos, and the components, an overview of the components architecture. Let me say that core part of my seminars will be on the different phases of the methodology, and in the end a description of the final output and how we can exploit such a result. The last 2 points are dedicated on a KDI knowledge and data integration course that is actually how we teach iTelos. And it is a way in which that we are using to improve iTelos itself, and how iTelos can see in a very general way. I will describe you what is called the iTelos big pictures. So let's start from the data integration. So why we need the data integration? To give you a bit of context, we can say that, as probably already you know, the data that we are using to describe the world and to understand the world are heterogeneous. So we can define the world as divided in data domains. So from the point of view of data, of course, the data in the data domain are included in dataset, and within each dataset we can identify different kinds of heterogeneity. Such heterogeneity is mainly based on different aspects that I listed here. So natural languages, for example, heterogeneity in terms of different languages used in the data, so English, Italian, and so on. Domain languages, let's think about, for example, in the domain in which I'm working, mostly, the health domain, we have different medical standards in which we have different concepts expressed through codes standardized by medical standards that can be seen as domain languages. Another level of heterogeneity can be defined by the data formats, so basically the schemas, how the data are represented, are structured. The dataset file format concretely, so we can have dataset included in a JSON file, XML, CSV file, whatever. And of course, a composition of all these kinds of heterogeneity can appear once we are managing the data set in a data domain. So in order to exploit the information that are included in the data, we need to manage such kind of heterogeneity. We need to exploit also that, because another synonymous of heterogeneity is what we call the diversity. So it's important to keep the strength of the diversity within the data. And how we can do that? So integrating this different data set using a process, so a set of tasks that we call a data integration project. So our idea of data integration project is knowledge-driven. So we use this knowledge-driven approach that now I'm trying to explain you. In this figure, you can see a general description of a data integration project. So basically, starting from in the left side, a set of heterogeneous data set. So from heterogeneous data sources, we want to provide a single, to construct within the data integration project itself, a single unique reference schema for such data. So all the different representations that we can find within the heterogeneous data sets are all represented and all maintained, represented through this unique reference schema. How we can construct such a schema? Using knowledge references, knowledge resources. So this is exactly the second input in our data integration project. So what is the goal? The goal is to obtain an output of a data integration project that is composed mainly by three different elements. The first one is knowledge graph, so what we will call also in this presentation entity graph, is a data structures that is able to maintain the data integrated, represented through the knowledge resources that we use it. So basically using the unique reference schema that we produced within the data integration project. And this is, let me say, the most important piece of the output, because thanks to this structure, we are able to exploit, to provide the usage of the data we integrated to external services, for example. And yeah, so the second part of the output, the final output, is a set of reusable resources. This is another important aspect related to our idea of data integration project, because the idea is that during the data integration project, we are producing different intermediate outcomes, and all these outcomes are resources that can be reused by someone else in future, for example. So keeping together all these resources can improve the quality of the work that will be performed in future by other users in the context of the data integration, or maybe in other contexts. So let's think, for example, to give you an example, to the data sets. So in a data integration project, we basically always have to manage the data set, so with cleaning and formatting operation, for example. So we are producing different versions of the data sets. This data set can be, of course, these different versions of the data set have more quality respect to the initial ones. So these data sets can be, of course, useful for future works. All their resources involved and managed within a data integration project are part of this set of reusable resources that we want to be part of the final output, so provide the usage of these resources for future works. And the third part of the final output is composed by the documentation. So the documentation of the project is important to allow external users or external audience to understand what is the work that has been done within the project on each resource that has been managed. So I will later add more detail regarding all the three components of the the final output, but this is the idea of what we intend as a data integration project. So starting from a set of heterogeneous data and driven by knowledge references, obtain as a final result this macro output composed by knowledge graph, usable resources, and documentation. So how we can address the problem of data integration through the data integration project using iTelos, that is a data integration methodology. Methodology means study of methods. So here iTelos wants to provide a development method for a data integration project. Study of methods. So we now iTelos in the current version is something that is consolidated, let me say, but is under developing because it's important to understand how to improve such methodology. So we don't want to stay fixed to this point. We want to improve. These slides aims to describe basically why a user should choose iTelos to perform his or her data integration project. So basically, what iTelos offers are these main 3 points. So first of all, a user support. So iTelos provides a set of tools allowing the user to perform complex operation on all the different kind of resources involved. So knowledge resources, data resources, managing dataset, defining and managing schemas, reference schemas and ontologies, and so on. So in order to perform such complex operation, iTelos offers some tools that allows the user to do that in an agile and more easy way. The second point is that iTelos provides resource support. So due to the fact that we said resources are very important for us, we want to provide for future work the resources that we are creating. iTelos provide organized system for the storage and the management of such resources in each phase, for each intermediate outcomes developed within the methodology. Sorry. And in the end, iTelos offers activity supports. So maybe the most important things here is that iTelos provide a well-structured phase-based process that guides the user through the different phases, achieving the different intermediate outcomes that have to be produced in order to be composed in the end and obtain the final output as we described in the previous slide. These are the features of iTelos, what iTelos offers. In the figures below, you can see a first definition of the main of the phases included in the methodology. So open project phase, inception, modeling, and knowledge and data integration phases, and closed project phase. This is how in general is divided the methodology. So now during the presentation we will we will see these phases more in details and phase by phase, one by one. So now I want to spend some words regarding the structure of the methodology and which are the users involved. So which are the roles of the users that have to work on the iTelos methodology. So basically, considering the knowledge-driven approach on for the data integration, the approach that iTelos is following, we can see a strong dependence between the data layer and the knowledge layer. So the data resources and the knowledge resources, because we want to integrate data thanks to knowledge resources that we want to use in order to represent such data. This is why iTelos, all the operations involved in iTelos are mainly divided in 3 different layers. So we can recognize the project layer, so including all the operations for project management, so role coordination between the users, documentation production, project presentation to external audience, and so on. A data layer, that is the management of the data resources. Later there will be a slide that will focus on the different kind of resources, but what I mean with data resources is all concerning the data set, the data we want to collect and integrate. So data set, data sources, the metadata providing important information about the data sets. And the third layer is knowledge layer. So due to the fact that we have these dependencies between data and knowledge resources, the third layer aims to manage knowledge resources. So external references of knowledge resources that we want to use, such as we will see later in a minute. We will manage references to different schema, different ontologies. But not only, also we will manage resources regarding a single concept adopted in such ontologies, or single words to describe a concept, and so on. So to make you a concrete example related to our internal aspects of the knowledge, we are managing resources for L1, L2, and L4. Due to the fact that we have these divisions between three layers, we have different roles involved in the methodology. So speaking about users that are working on the methodology, we have the project manager, so the person in charge of the project layer, basically, a data scientist and a knowledge engineer, and a domain expert. That is, data scientist and knowledge engineer are respectively the users in charge of performing and managing operation for data and knowledge layers. And domain expert is important because in the beginning of the project we have to understand clearly the domain in which we are operating. We cannot think to perform a data integration problem without having at least one person that has clear in his mind, his or her mind, the nature of the data we want to integrate. Data, in this case, I mean also representation of the data, so knowledge and data itself, so data sets, the data included in the data set. In the figure here, you can see how the different roles are involved in the different phases of the methodology. So in the first phase, in the open project phase, we have a collaboration between the project manager and domain expert to set up basically the project and to define the domain in which the project operates. The inception, modeling, and knowledge and data integration phases are the central phases of the methodology and are divided between the work of the data scientist and knowledge engineer. That is not something that, I mean, there is collaboration between data scientist and knowledge engineer are not exactly divided. So they have to work in parallel, but also it's important that they have to communicate each other. And in the end, in the cross-project phase, we have basically a definition of the final, a finalization of the final outcome on the ends of the project manager. Okay, as I said before, in this slide I want to present you the resources. So in terms of concretely in terms of files involved in the methodology. As you can see, we have always this division between data and knowledge resources, and here I also added the documentation part and the composition of the file and output. So starting from the data resources, we have, of course, the data sets that can be filed in, as I said, in CSV, XML, JSON, or whatever other format. A data sheet that is a specific spreadsheet. So to make an example, just using an Excel sheet, for example, in which we have to provide some information regarding the dataset. So, for example, the data sources, where they came from, and the list of the dataset involved in the project, and so on. The metadata are also an important data resources that we can define using a DCAT standard. And data management libraries. So basically, these libraries are a set of pieces of code, concretely speaking, that the data scientists often use during the project to clear the dataset, to format them, to filter or scraping if it's necessary the datasets. So all these code scripts, for example, are collected and have to be. We want to keep such artifacts as part of the resources that we want to provide as reusable resources. Yeah, so a note that I want to add is that basically when you have to think about reusable resources in the final output, we are considering more or less all these resources, so data, knowledge, documentation, and file output. So let's move on the knowledge resources. We have an inception sheet, another important spreadsheet that is basically here in this sheet are reported the first definition of the elements that we want to use to produce the unique reference schema for the DI project. Here I didn't add an example of this sheet, but if you want, I can provide you such example. But just to summarize a bit the information collected there, we have there the starting from the reference of the competency queries that we defined for the project. I will describe these queries in a minute. We have all the possible elements defined in this file for that we need to create the reference schema. So basically the classes, the properties related to the classes, the word that we choose to represent such classes, and so on. We will use this inception sheet to construct the real schema. The real schema that will be in a form of an RDF OWL file, so the second set of knowledge resources that are the ontologies in which the schemas are defined. Both the resources, the schemas that we want to produce specific for the project, so within our project, both the external schemas that we will take into account as references, as I will discuss later in a minute, are both represented as ontology in RDF OWL format in iTelos. The third point regarding the knowledge resources is the ER model, that is a graphic version of the unique reference schema we want to produce. Is important because it allows it allows the user basically to have a clear understanding of what the schema includes. And basically this is a graphic tool format files, for example, defining an ER model, and yeah, for example, the output of a tool, for example, like YID could be a representation of such resource. Then the documentation resources is composed by a domain definition document in which are defined very important information regarding the domain of the project. So basically here is defined the domain in which the project lives. So the data domain, as I described it in the beginning. Here are reported, as I said before, the competency queries. So basically how we want to exploit in the end the data, the information that we collected that we want to integrate through the project. Thanks to these queries, we can extract in the inception sheet, as I said before, the main object. So basically the involved in the project. So basically the competency queries are the requirements for the whole project. So this text document is very important to understand, to guide from the beginning all the project, the data integration project, following the methodology. Then we have a project report, project presentation, and project demo. These are documents that aim to describe the work that has been done in the project. So basically, in a project report, you can have a detailed documentation regarding the work that has been done during each phase, which were the weak points, for example. So if some operation has been performed respect to others on the data sets, on the knowledge resources, and so on. The presentation slide instead, together with the demo, aim to describe to external audience, so in other words, to sell the final results to external services, to who want to exploit our results, basically. The demo could be, just to give you an example, can be for example a demonstration of the fact that the final outcome, so the knowledge graph, contain and can be exploited to answer the competency queries that are defined in the beginning of the project. The final output, instead, as I already described you a bit, is composed by the entity graph, that is our knowledge graph. Usually we can see this as a file in RDF or EML format. EML is our internal format to represent such structure of data. I don't want to spend too much details on that, but we can of course provide you more details if you want. And the project documentation, so basically all the resources listed before, and the set of usable resources that are basically all the resources involved in this slide that I described to you right now. So let's move on to see what is the components architecture of iTelos. So basically, in this figure, you can see how iTelos is integrated and connected with different components in order to follow the different phases of the methodology. The most important component application for the iTelos methodology is the one here in the center of the figure, so the COS web application, and COS is state for knowledge operating system, and it aims to be the application that guide the user through the different phases. That is why the iTelos business logic is located in the center of this application. The application is basically composed by two different subcomponents that are the COS core and COS UI. The COS core is the connection point with other external tools, such as the project repository that is connected with the project catalog. So basically, in this right side, we have the possibility to store and to provide the access to the resources that we are producing during the project, and is connected with Karma Linker, that is one of the most important tools involved in the methodology. It allows to merge, to map the data with the Unix schema, reference schema that produced during the project. All the COS application is strongly connected, and basically it works thanks to the DI platform. So the data integration platform is a very important part of our work of the iTelos methodology, because it basically contains the structure of the knowledge base, and the entity base. So basically, it can contain the structure, storage, and maintain the structure at each level of all the knowledge resources involved. It can contain the entities, so at data layers, and provide this API layer, so the API of SCORE, allowing the other components to communicate and to exploit what is stored and maintained in the data integration platform. In other words, we can say that in the data integration platform is where a knowledge graph can live, and so can be also exploitable once is completed. Yeah, so as you can see, the users interact with the COS UI component of the COS web applications and is guided through the different phases. It can also have an interaction with external tools, because in some parts of the methodology, the users can choose if adopt external tools to provide the correct output in the methodology. So those are input, sorry, not output. These inputs will be, of course, checked by the methodology itself in order to be sure that the inputs are compliant to what the methodology wants in order to perform the internal activities. So this is exactly the point of view of the components involved. Instead, here we have the point of view of the process, so the activity process diagram of the iTelos methodology. And we can see also this diagram from the point of view of the COS web application. So let's think the COS web application as a state machine, for example, in which each state is represented by the different phases of the methodology. So the 6 main phases that are here reported. And in each phase, we have an input that has to be taken, each phase has to perform some activities in order to manage such input, and sometimes produce an output that can be managed by the next activity, for example, in some cases. What is not presented in this slide is that after each phase we have an evaluation step. So basically, if what is produced in each phase is not compliant with the methodology, in this case the COS web application will move back to the previous phase, and so we'll ask, for example, the user to correct some errors, to understand why there are some errors, providing some log, and so on. Okay, so the idea is to provide in future, we hope early future, an automatic version of such process. Now it's the semi-automatic. Of course, the involvement of the users is strongly involved in this process. Now let's go to see phase by phase how this process is performed. We have this first phase, open project, in which the most important layer involved is the project layer, in which we have to, the objective of this phase is to set up all the project environments. So basically the Git repository, for example, I'm using Git because is our tool in this moment to organize the data as repository. The environment for the documentation production, so for example overleaf, and also the catalog environment, so the CCAN application, for example. In this phase, all this environment has to be set up, and the input in this phase is the domain document definition, as I described. Use this important document defining where the project lives, and so the context, the competency queries involved, and so on. There is no concrete output in this phase, and the tools used are, of course, COS, that is basically always involved, and the documentation environment to write such kind of document. In a second phase, that is the inception one, we have the definition between the data layer and knowledge layer, because from the side of the data layer, we have the objective is to collect data set. So the data scientist has to collect all the data set considered as important in order to integrate the information we want. for the project, and to define the data sheets. So I described you before such a sheet, and that is part of the input of this phase. Instead, for the knowledge side, we have the definition of the inception sheet, in which, as I said you before, we have the definition of all the elements involved that we require basically to define our reference schema. In order to do that, we can already at this in this phase to consider a reference ontology. So, for example, if we wanted to describe something related to the personal or social aspect of the people, we can use FOAF as a reference ontology in order to identify which are the possible elements that we can we want to reuse in our project, taking them from FOAF, from the reference ontology. That is why we want to produce resources and to keep reusable resources as final output, because, for example, the resources that we are producing during our project can be reused in future for future project as reference ontologies. Also in this phase, there are no concrete output in both the two layers, and the tools involved are COS and, of course, a spreadsheet editor to produce the two sheets. The third phase is instead the modeling phase. In this phase, we have both the knowledge and data layer. So from the data layer side, we have to clean, filter, and format the dataset that we have previously collected. Instead, for the knowledge layer, we have to define having a reference, and so having we have already choose the reference ontology that we want, maybe more than one, that we want to use to model our solution, our reference schema for our project. We have to compose another part of the schema that is includes all the definition of the elements that we cannot take from the reference ontology. So this is a specific solution ontology, so an ontology more specific to the project. For this, in this phase, we have to basically upload as input in the knowledge layer both the solution ontology and the reference ontology, and the ER model that is this graphic version of the schema we want to produce. The output of this phase is an automatically produced ontology merging proposal. So the idea is to perform a component in an activity, so a subtask of this phase that is able to propose how to merge the reference ontology with the solution ontology. In the knowledge integration phase, the idea is to merge, so to perform all the merging operation between the two ontologies, the reference one and the solution one. Okay, so basically in this phase, the role of the user is important because okay, we have the ontology merging proposal, but it's the user that has to decide how to merge, how to compose a final version of our reference schema that is also called an E-type graph or ETG, that is here expressed as output of this phase. The import file here is represent L1, L2 import file is produced in this phase because if we need to import in the data integration platform where all the knowledge resources are stored and maintained in order to create the final reference schema, we need to produce such import file in which all the new resources for L1, L2, so basically for language and concept, are included in order to be imported in the data integration platform. And yeah, so regarding instead the data layer, we have to collect and define and upload all the definition of the metadata associated to the resources involved in the project. So at each level, so for the knowledge resources and the data resources. And we can use, for example, in this case, involved the CCAN tool for the catalog, because the metadata has to be part of the catalog project. Instead, for the knowledge layer, sorry, I forgot to mention that the tools involved are, of course, COS, knowledge management tools that can be Protégé, and the data integration platform in the case in order to import the resources we need to compose the final schema. Let's move on in the phase number 5, that is the data integration. In this case, in this phase, the knowledge, as you can see, the knowledge and data layer are merged together. And the objective of this phase is to map the data set we collected and we formatted, cleaned in the previous phases, to merge with the ETG, so the reference schema we produced in the previous phase. So in this phase, the most important tools, as I already mentioned, is Karma Linker, that allowed us to represent each data set collected in our project through the object classes and properties defined in the reference schema. The output of this phase is the mapping output. This is that we can say that this is a first instance of the final knowledge graph, so of the entity graph. But we have to import this output in the data integration platform in order to perform such operations like ID management, entity management in case of duplication of different representation of the entities and so on. And only once the mapping output is imported and the data are integrated in the data integration platform, we can say that the data can be exploitable and the entity graph is finalized. In the cross-project phase, that is the last one, we have the object is to finalize the documentation for all the projects, so to complete all the resources that are missing for the project, and to provide eventually a presentation of the project and a demo if required. Okay, so in the end, we have the final output. I want to spend some words on the final output because, as I said, once the entity graph is maintained in the data integration platform, the data are correctly integrated and exploitable. And what we can do with the entity graph, we can export it from the data integration platform in form of EML or RDF file. We can exploit the entity graph directly on the data integration platform using, for example, that is stored, in the data integration platform using a SparkQL endpoint, for example, like GraphDB. We can demonstrate how the competency queries that we defined in the beginning are correctly answered. Or we can evolve such entity graph, because iTelos has been studied basically to offer the possibility to add data to the knowledge graph, but also to increase the knowledge resources, so to improve the reference schema we produced initially. This is another step of the overall methodology called the evolution phase of the evolution process of iTelos, and it's a very important next step of our work because it allows to increase it will allow to take an already existing entity graph and improve that from the point of view of data, both data and knowledge resources. Okay, so actually this methodology is, as some of you already know, is taught in the KDI course, in the knowledge and data integration course. That we are doing here in Trento. The KDI course is very important for us because it allows to identify, as I already mentioned, the weak points, weak and strength points of the methodology, and so we have the possibility to improve several aspects of the methodology. Already in the previous version of the course in 2020, you have the link to the website of the course in this slide. We identified different aspects, and already in this year, in 2021, we have a new version of the methodology that is more concrete, that is more structured. We solved some problem starting from what we discovered in the previous edition the KDI course. This is why our idea, and we are already collaborating right now with a different university to teach KDI in different environments, in different university. More in details, we have a collaboration with the Dublin City University, with the Jilin University in China, and with the University of Mongolia. And the idea is to teach the course, of course, to provide the knowledge on these fields in the other university, but also to provide, to generate more resources from the project that will be performed in each university using the iTelos methodology. Let's think about the set of reusable resources as part of the final output of iTelos. Of course, this set of resources will be in the context of the Mongolia University, in the context of China, and so on. So we will have a very huge quantity of heterogeneous resources that can be reused later. Next year, for example, in the next editions of the KDI course, but also for concrete real purposes. In the end, this is the last slide that I want to show you. As you understood, I hope, from my presentation, iTelos is a very core component of our works. So it basically it is connected to the work that we are performing in our group in different aspects. So, for example, for all the works related to the platform, so for what concern, for example, the platform instead, the knowledge and the entity base, the karma linker work, so also including the NLP tasks that we are performing and all the operation for the machine learning tasks that are included in our platform. It is connected to the work on the catalog, because the possibility to provide our resources is very important for the iTelos methodology. It is connected to two different university courses, KDI, of course, as I described it, but also study and human behavior, because that course allows the user to collect in a very clear, concrete, useful way the data that we can use within KDI. So the idea is to connect as a chain these two courses in order to develop a data integration project starting from a very good shaped and very useful data. And on the right side, you can see that iTelos is strongly connected to the possibility to provide online all the different levels of resources that we have. So in terms of language, data schema, and also the people data. And so basically, to summarize this four connection, we have the possibility to share online, thanks to the iTelos methodology, resources for L1, 2, L4, L5, and L7. So basically everything. So this is why I showed you this image, because iTelos is very strong connected to all the aspects involved in the work of all of us, basically. And so I finish. I hope to be in time, more or less, and I'm happy to answer all the questions that you can have.
Thank you, Simone. We have 10 more minutes, guys, so hopefully more questions. I don't see any raised hands or chats yet. Okay, Danish, go ahead.
Hi, Simone.
Hi, Danish.
Thank you very much. This was a very nice presentation. Actually, it cleared a lot of my doubts, which I had over past few months. Thank you very much overall. I just have a small question, because it was very detailed and I could almost understand all of the steps which were going on. I was curious about the provenance for the data integration phase. How do you manage in the part where data is coming from different resources, and how are you managing the provenance part of the entity level and also the data set level?
Okay. Yeah, thanks for this question, because it's a very important aspect regarding involved in the methodology itself. I didn't mention in specific the provenance, but of course it's considered as part of the metadata we are collecting for every kind of resource involved in the methodology itself. The idea is to keep trace of the provenance for both the data, so the data set involved, not only the data set at data set level, but also at the level of the single data included in the data set, and also for all the knowledge resources that are both collected from external sources and both generated from within the project itself. And so how the provenance is managed? The idea is to we have already structured a new version of the data integration platform that will be able to maintain such information. So the idea is to, as I said, to link to link the provenance to each kind of resource managed within the storage of such resources in the data integration platform. So both in the knowledge base and the entity base. And I don't know if your question was more specifically related to some aspect of the provenance, or I already answered.
No, this is okay. I mean, we can discuss it later more in detail, but thank you very much.
Okay, you're welcome.
Amara asked a question in chat. What is the ETG?
Sorry, what is? Let me read. ETG, okay. So ETG, let me back to the slide in which this one. ETG is another name, stands for E-type graph, and is another name of the, actually is the official name of the reference schema that, so basically the unique reference schema that we want to use in the data integration project to represent all the different data collected and involved in the project.
Thank you. Marcelo has raised the hand. So go ahead.
So thank you, Simone, for the presentation. I just have a simple question. In the first phases, phase 1, 2, and 3, I think also 3, the output is none. So what's the relation with the, I mean, could you elaborate a bit of the relation of this? I mean, what do you mean with output there? If there is no output, why are you doing that? I mean, or what do you mean with output?
Okay, nice question. So maybe you can use this image to answer. And yeah, so basically, sometimes, as you highlighted, this sometimes we have an output in some phases, and sometimes we have not. The idea is that especially in the first 2 phases, we have to collect the informations and the resources that we need to perform activities, to perform subtasks in the methodology. So when in this case, for example, taking into account the state machine of from the point of view of the COS web application, the idea is that in the first 2 phases, we can go on in the next state. So the machines allows the user to go on in the next phase only if the input is correct. Okay, so without checking and without producing an output resource. In the other phases, so starting from modeling and until the close project, the activities within each phase has to produce something in order to go on, has to produce a result that has to be used later in the next phase. So the course web application will allow the user to go ahead only if such output can be produced correctly. The idea is that we have not exactly, as you mentioned, a strict definition of output, but the idea is that we want the output is required only when we have enough resources to produce something that can be useful for the next phase. This is the idea. And of course, in the beginning of the methodology, in the first two phases, the users has to collect some resources in order to perform other activities later.
Thank you, Simone. Gabar?
Is it my turn?
Yes, please.
Okay. Thank you for the presentation. So, of course, we are in the same boat, right? We are applying this in Interoperate, among others. So, I have a question with respect to the pipeline that you showed in the beginning. So, this work. This problem is very much about automation, right? So usually we have a lot of data and we have to automate this process to some extent. But if we automate, this means that necessarily there will be errors, in mistakes or different kinds of mistakes in the process. So validation becomes a crucial element. And I was wondering whether validation is included in your pipeline explicitly. Maybe you didn't present it because you stayed on a higher level, but I think that it should be an important element of the pipeline to validate the results and to have a mechanism to improve the results in case there are mistakes found.
Yeah, I perfectly agree with you, Gabo. And actually, yeah, that is maybe one of the most important things that I forgot to highlight in my presentation. The referment of that was I said that we have. Can you hear me?
Yeah.
Okay, sorry. We have at the end of at each phase this evaluation step. So this evaluation step is very is much more complicated and useful and important. Respect the few words that I spent on that in the presentation. Of course, we. Together with Fausto and Rui, we started already to write some to perform some research for the evaluation. So specifically for the evaluation. So I agree with you. The evaluation is a very important step, and of course is included as part of the methodology as because it's. I mean, the final results and most important, the intermediate outcomes for each phase are strongly dependent on how the validation and evaluation phases are performed after each phase.
Okay, thanks.
Thank you, Gabar. Mayuk?
Yeah, am I audible?
Yeah.
Yes, so I had a question. So in one of the, slides near the beginning of the presentation, there was a diagram depicting the division of roles like
This one.
In which phase? Yeah, exactly. So is there any role of this project manager in this inception modeling, knowledge integration and data integration, or it is just at the beginning and at the very end? So this was my...
Okay, yeah, thank you for this question. Yeah, of course, it is important. In this slide, I provided a division of the different phases of the methodology respect to the user roles, but just to highlight the fact that the most important operation performed in each phase are related to the project manager and domain expert in the first one, the data scientist and knowledge layer in the central ones, and so on. But of course, the idea is that to perform, to develop a data integration project using the iTelos methodology, the idea is that I mean, there is a team that is working on the project, and the collaboration among the different members of the teams is crucial. And in each phase is important that the collaboration of the different user and user roles has to be, they have to keep attention in the collaboration in each phase. So of course, for example, in the inception phase, the most important roles involved are the data scientist and the knowledge engineer, but of course the project manager has to follow the process in order to understand, also because he or she will be the person in charge to write the documentation. So it is important also for the project manager to understand which are the operations that have to be performed in the inception phase as in the other phase. Together, in the same way, the data scientist and knowledge engineer has to take into account, for example, the consideration and the opinions expressed by the domain expert, because otherwise they cannot work on data without an understanding what the data are talking about. This is the idea. So there is a strong collaboration, more than this figure expressed, but of course this is in general the macro division of the roles against through the methodology phases.
Thank you, Mayuk. Samuel?
So, hi Simone, can you hear me?
Yeah, I can.
Well, first of all, I want to thank you for the talk, because it's really interesting, and I find it amazing the way you created an architecture. We created an architecture so complex and so organized to deal with the data. And my question is about L1, L2, L4, which you talk about in this slide. I don't know what they are.
Good question. A very big one, maybe. And yeah, so I try to summarize a bit this very huge topic. So basically, L1, L2, and L4 is the different levels of resources, level of heterogeneity, level of information, data that we can manage within a data integration project. And more in specific, this is the name associated by those kind of resources in our group. So when we are talking about L1 and L2, for example, we are defining resources related to the language, so the natural language or domain language that we want to consider in a data integration project, so related to the data. So also the single concept associated to the data. So for example, if we want to define a schema in the data integration project, that is exactly what we intend as a resource of L4, we have to construct such a schema with classes and properties. To each classes and to each properties are associated concepts. So for example, if we have to associate to create a schema in which one of the classes is house, we have to associate a concept to the house. A concept is part of L2, and we can express house in using a word in English that is part of L1 that is related to the language. This is the idea. Okay, so it's a division of all the possible resources that we are managing in a data integration project.
Okay, thank you.
Thank you, Samuele. So with the Fausto's observation, we will close this week's seminar. Fausto?
Yeah, I wanted just to point out that clearly right now we are integrating data which are static, but that with a little bit effort, I think this will be generalized to integrate in streaming data and streaming data and static data. This is where we're going, because of course we will need to integrate the data will come from static resources, from data will come from the phone, from calendar. We will do this next year after the summer. First, we need to consolidate. Point I'm saying that ultimately our general goal as a group is really to come up with a general methodology for integrating all types of data. 2022, we integrate videos inside, images. So all different forms of diversity. And this is our general mission. So this methodology is really reaching, and I really think that the work done by Simone and all the others, like the group, I think is really now crystallized very solid that we can generalize to all the types of data. I hope you heard me because I was far from the microphone. Anyhow, good, thank you. Simone, there was no question for you. I already asked you.
It's okay. I mean, we have a lot of stuff to discuss, so we have time.
By the way, I think we will put this video on the group. I think this slides and lecture, I think is very significant for the group. I think we should make everybody listen to this lecture when joining the group. So I will put it in the group video website. I think it's a very good introduction to iTelos, so that in a sense is the overarching approach and methodology integrating in perspective, which is a general program to integrate the diversity of data into a single global view. And then, of course, since Matteo is online, I don't know whether next year, in 2 years, this will be the way by which we merge the data coming from the data science course in KDI.
Hello? So, Fausto?
No, I'm done. So
Okay.
I just make this observation.
So thank you, Fausto, for making the final observation, and thank you all for joining. And by the way, Simone, it was really wonderful presentation, and all the best for your further research and all the works. And thank you all for joining this week, and see you next week. Ciao.
Thank you very much.